All right. So we left off with number 4. I'm actually going to redo number 4 real quick because this one kind of transitions us into number 5. And number 5, you're going to find a little bit weird, a little bit harder. So I want to make sure we have 4 fresh in our minds. So what we did yesterday, I told you with number 4 that Roman numeral number 1 was a square and it had an area of 36. So number 1 was always this bottom left-hand corner. So we drew this so that it kind of looked like a square. And then we knew from the setup of the problem that Roman numeral number 1 had an area of 36. We also then, when we set these up, and when I say all of these are based off the same thing, it was based off of this diagram. So this was A, B, C, D, and then we went 1, 2, 3, 4. Oh, I'm not sharing. It's good to know. Nope, they're just too nice of a group. They didn't want to call me out. Yeah, all right, should be sharing out now. Sorry. All right, so now we were talking, here's how we set all these up. This was always Roman numeral number 1, 2, 3, 4. This was A, B, C, and then D. So when we came down here, you were told that Roman numeral number 1 was 36. You were also told that it was a square here. And because of that, we can conclude that a square, if all sides are congruent, this had to be 6, and then that had to be 6. You were then told, so we called this B. So let's finish drawing these out. You were told that the B right here was 10. So we put the 10 here. If it'll let me erase. There we go. It is slow though. And then D was 4. And then this was 4. So then using all that way around, we were able to figure out this area by doing this base of 6 multiplied by the height of 4, so an area of 24. This rectangle had a base of 10, and then this height would have to be the same as this height, so we did the 10 times the 6 to get 60. This base was 10, this height was 4, that's going to be 40. We left off there yesterday. What I want you to now do, if I ask you to find the overall area, so write this down, because this is how we're going to kind of transition into what we're going to be doing on the next problem and then really for the rest of the week. We have 2 different ways that we could do this that we talked about yesterday. So option number 1 now, if I wanted the area of the big rectangle, the overall rectangle, we could just do 24. Come on. We could just add up each of those individual areas. So we could just do 24 plus 40 plus 36 plus 60. So that's what I'm going to do first. So 24 plus 40 plus 60 plus 36. That will give us 160. So that's one option. Just add up each individual rectangle. Option number 2 is we could do the overall big base multiplied by the overall big height. So if you look at the overall rectangle, if I ask you what is the length of the base of the big rectangle, would we all agree it would have to be the 6 for here plus the additional 10, so that the overall base we would say is 16. We would then multiply by the overall height. So here's our overall height. Well, part of it is 6. The rest of it is 4. So if I just did 6 plus a 4, this whole length over here would have to be a 10. So if we did the overall base, overall height, we multiply those together, you're going to get the same exact area that we would get if we added up each of those 4 rectangles individually. Okay? So that's what we had finished yesterday. I want to make sure we see this because we're going to talk about very, very similar thing here in the next problem, but you're going to find it probably to be a little sneakier and it'll make you think a little bit more. Okay, but that's what we finished up yesterday. So now go to number 5. Let me create a little space here. And let's first start by drawing in our little diagram. as best you can when you read this, the area, suppose area number 1 is a square. So as best you can, when we draw this in, try to make the lower left-hand corner at least look like a square. It's not terribly important, but as a nice visual, we will. And then we'll draw in the rest of this. So we'll draw in something that looks like this. And then if you remember, this was A, this was B, C, D. This was Roman numeral 1, 2, 3, and then 4. That's how all of these got set up yesterday. So now let's fill in some things. It says, suppose area 1 is a square with a side length of x. So area 1 is a square. Each side is an x. So what that really tells us is that A and C have to have a length of x. All right. If we read the second sentence, the area of number 3 is 6x. So let's come up here. I'm going to get rid of number 3. And you are told that that area isn't a simple number like it was in the previous problem. It's a 6x. If we continue reading that sentence, the area of number 4 is 30. So that one's a little easier to understand. We're going to get rid of the Roman numeral 4, and we know this has an area of 30. So now, what I want you to do is fill in the rest of this. You're going to tell me what is the area of Roman numeral number 1, what's the area of Roman numeral number 2, what's the length of D, and what's the length of B. Okay. Now, when I say that, we'll walk through this one together, but that's what we want to look for. So the first thing I want you to find, so think on this for a minute. Tell me what you think the area of Roman numeral number 1 would be. Anybody think they could tell us what the area of Roman numeral number 1 would be? What are we going to write in that square there? Alexis, what do you think? I think you just froze, Alexis. Can you hear me? I didn't hear. Oh, hold on. Why can't I hear it? Say it again, Alexis.
Would it be x squared?
Oh, there we go. Yeah, you just went on the speaker for that. I don't even know how we did that, but you just went on the speaker in the room. Who knows? Good. So for those last period, a lot of blank stares with this question. So what we did is we revisited this. If I ask you to find this area, this 36, don't we really just do the 6 times the 6? We multiply the base and the height together. So just because there's no numbers there doesn't make this anything different. So what Alexis said was x squared, because all we're going to do is take the base, which is x, multiply it by the height, which is x, and we just get x squared. X times x is going to give us an x squared. All right, does that make sense? So that's what we're going to put for the area of number 1. We would just say is an x squared. So we don't get a numerical value, we get a variable term. All right, number 2. The next thing I want you to do is tell me what you think the little d is equal to. So here's the little d. What would d have to be equivalent to? I kind of want to call in somebody at home again so I can hear that. I don't know how I did it. It wasn't doing that yesterday. No. She was delayed though. Like I saw her lips move, and then it was like half second later, it popped up here. Probably. All right. Anybody think they have D? What would D have to be? Cameron. Let's see if we hear you, Cameron. Say it loud and proud.
I got 6.
We heard you. Yes. I'm very amused by this. Good. How'd you get 6, Cameron?
Because 6 times x would be 6x.
Good. So she looked at this 6x, and it's just a product of a 6 and an x. Well, the x comes from down here, so the 6 would have had to have come from right here. So that we would take this, multiply them, get us our 6x. All right, very good. So D is going to be 6x. 3 and 4 real quick now. Number 3, give me the area of Roman numeral number 2. And then tell me what little b would have to equal. Really? It's so exciting. It's amazing what we get excited about right now. Yeah. That's right. All right. To guide you a little bit, you have to figure out the B first. You can't do the other one without knowing what B is. So B is the one that we need to figure out first. All right. Anybody confident in what they get for their B? Gail, what do you think, bud? Good. And where'd you get 5 from? How'd you get that? Good. So what he knew is this rectangle up here has an area of 30, and the height right here is this 6. So then he just said he had to do 6 times what to get a 30, and that had to be 5. So that the 6 multiplied by the 5 is going to give us the 30. All right, good. So the B is 5. Then I assume you got the area for number 2, Gael, once you have that. What'd you get for that? Good. And then we just do our base of 5 multiplied by this height right here, which would be the same as over here, x. That's our height. All right. So now, same thing we did last problem, though. So let's draw this in. If I ask you for the overall area, so we have 2 different routes to take here. So if we talk about option number 1 again, all we did on the previous problem for option number 1 is we just added all of these up. Each individual rectangle, added all together, should give us the overall area. Here's how I want you to write this, though. We want to put the square term first. So we would say that our area would equal x squared. That's this one first. And then we're going to put the 5x, so plus the 5x, plus the 6x, plus the 30. When we do that, we should see that we have like terms here. So we're going to be able to combine these guys together. So we'll get x squared plus 11x plus 30. That's your answer. It looks weird. You're not getting a numerical value right now, but that's the area that we would say for this rectangle. What you are looking at, the reason we're going to do it in this order. So see how this has a power of 2? Oh, it didn't erase good. The way we are writing this is what we call descending order. So notice how this power of 2, then I put my power of 1, and then notice how this last one doesn't have an x, because we could say it has a power of 0. When we write these out, we want them in what is called descending order, and it's based upon the exponent in your variables. So that is why we would want to go power of 2, power of 1, power of 0. That's why we go that order. Okay. Now, we also had option number 2, right? Option number 2 is to just take the big base and multiply it by the big height. So again, don't overthink. Don't think it's anything different than what we've been doing. If I go back to the previous problem, this big base was just the sum of the two terms along the bottom. The big height of 10 was nothing more than the sum of the two smaller heights along the side. So we are adding those two values together. So on to this one, it's the same exact thing. It's just going to look weird, and you might find it to be a little harder, but it's the same exact thought process. Our area would be the big base. It's the sum of this, and then plus this one. So we would write x plus a 5. And then we're going to put that into parentheses. I'm going to multiply that, so times my height. I just cut out. Am I frozen? For absolutely no reason. I don't know. Can you hear me now? Now can you hear me? Yeah. But I'm not sharing the screen anymore, right? All right. Give me a minute. Just got booted. Sharing. See it? All right. So what I had just written, our base was the x plus the 5. We're going to multiply that by our height. So our height now is this x increased by the extra 6 here. All right. This is something we did a little bit of in the first chapter. We talked about a little bit. We didn't really test you much on it because we're going to do a bunch of it now. It was just kind of a little warm up for what you're going to see in this chapter. Remember how we multiplied these together? We called it foiling, but all it really, we're going to take the x, and the x has to get distributed to each term in that second quantity. So we would do x times x, which is x squared. The x times the 6, which is a 6x. Once we had done that, you're going to take your 5, multiply it by x. So this is going to get distributed. And then the 5 times the 6 would leave you with 30. So now look at what we have up here. When we added these individual rectangles together, isn't that the same thing we just got right now by multiplying those two polynomials together? All right. Now we'll clean these up. We'll put it in descending order. So we want the x squared next, or first. 5 make 11, and then plus our 30. And then now we see same answer here as we just got right there. All right. All right. So yeah, definitely. All right, I'm going to leave that there. I see some of you looking. Go to the next set of problems then, if you've got this copied down. And it says using area models, which is what we've just been doing, those last 5 problems, to multiply polynomials. And that's what we just did right here. Polynomial just means we have more than 2 terms. We were multiplying them together, so an x and a 5 multiplied by an x and a 6. All right, so this one we'll walk through together, and we'll see if this makes sense. All right, so it says, for example, label the dimensions of the given rectangle with x plus 4. So notice how there's a little plus right here. And then there's 2 different things added up, an x and a 4. So the way we're going to put that, we're going to make this our x. That's going to be the base of the small one on the bottom. But then what we did is we would add an extra 4 here. So the overall base is x plus a 4. If that makes sense, label this guy now. So label this side. How would that get labeled? All All right, I'm not going to call anybody yet because first time we're doing one of these and it's not necessarily intuitive. We would call this our x. That's this part of it. And then we're just going to tack on an additional 7 to make the overall bigger rectangle. All right. So here's what I want you to do first. Before we actually read here what this is telling you to do, what I want you to do real quick, find the area now of these 4 individual rectangles. Similar to what we did in the last problem. Write down the 4 things we should get in those 4 rectangles. All right, let's see what we got. Anybody share out what this one is? What would we think for that one? Cameron?
X squared.
Good. It's just the base times the height should be x squared. All right. Anybody share out this one? So the bottom right-hand corner, this was our Roman numeral number 2 when we were putting the Roman numerals in there. What do we think for that area? All right, Gail?
4x.
Good. We're just going to take this base of 4. We're going to multiply it by this height right here, which would have to be the same height as over here, which is x. And then if we get to this one here, what do we think? Go Thalia. What do you think, Thalia?
Would it be 7x?
Good. The base of x multiplied by our height of 7. And then this one actually is the nicest one. It's the one that probably makes the most sense that we've been doing for a long time. Victoria, what do you think for this upper right-hand corner there?
28.
Good, 28, because it's the base times the height. Those are actually nice numbers. So now, if I ask you this question now, find the area of the entire rectangle. We have our 2 options, and we want to know how to do it both ways. So option number 1 is just add them all up. Add up those 4 yellow rectangles that are on my screen. So the x squared plus the 4x plus the 7x plus the 28. We just add them all up. Like the last one, we have some like terms that we're going to combine. And also like the last one, notice how we're in descending order. We have the squared term, the x to the first term, and then this doesn't have any x's, so 0. Now, long term, option number 2 is the one we're probably going to really focus on. But we better get the same exact thing we got by finding each individually and adding them all up. So option number 2 is taking the overall base of this x increased by an additional 4 and then multiplying it together, just base times height, with this x increased by an additional 7. Do that real quick. We did that a handful of times last chapter. We did one today. Make sure we can get through all of that. It's a really simple little check because if we do it correctly, we better get the same exact answer that we just got on the left-hand side. All right, they should be identical. And then hopefully we get the same thing over here. You know you're right if you get the same answer we just got. We would do our x and the x, so 7x. plus the 4 in the x, and the 4 in the 7 to make 28. Add up our like terms, get 11x plus 28. And then now this answer, delay there, is the exact same answer as the one that we got over here. The other thing I want you to now recognize, because this is something we're building towards that you're going to want to see in our boxes. Notice how these guys, these two corners, notice how those are your like terms that we're adding together to get that middle term. All right, that's not a coincidence. We want to recognize that pattern. If I come up to this previous question, the exact same thing would have happened. So the whole thing just moved. Take these diagonal two, add them up. Whoa. Let's try that again. If I add these two diagonals together, notice how that's what our like terms are in here, and that gives us our middle term. So the upper left, lower right end up being our like terms that we could just combine and add together. Okay? All right, so now let's see if we can get this next one done. All right, number 2, let's start with this. See if we can label this rectangle. That's all I want you to do to start. Label the given rectangle with these dimensions and see what we think. How would we label that? Okay, what we hopefully see, or did, and I'll kind of walk through here, this should have been a 2x, so that gives us, I'm going to do this one first, and then what we would have done is that original 2x gets increased by an additional 5. If we did this one, this would be 2x also, and then we increase that by an additional 1. If you have those flip-flop, it doesn't matter. Okay, it'll still all work out just fine. From there, I want you to find the area of this rectangle. Gosh darn. So now, however you think you would find that area, do it. We've done it 2 different ways in the last couple of problems. Find the area of the entire rectangle. We'll probably finish here, so I'll give you a minute or 2. And whatever way you think is the best way to find that area, go ahead and do that.
Hi, Amber. Please excuse the interruption. Just want to give a couple of quick announcements as we approach the lunch hours. Want to share with everybody, freshman lunch is held in the commons. All freshmen will be eating in the commons. Sophomores will be eating in the Eagle Gym balcony. Juniors and seniors will be eating in the East Gym. And please note that almost all freshmen and sophomores do have a study hall. Most juniors and seniors do not have a study hall. Anybody with a study hall on their schedule should plan to attend that study hall. Juniors and seniors, most do not have a study hall. If you are purchasing lunch, please do that before you report to your location. Again, freshmen will be eating lunch in the
Can you hear
commons,
this?
sophomores in the Eagle Gym balconies, juniors and seniors in the East Gym. If you're purchasing lunch, please do that before you report to your location. And there are no off-campus passes for lunch. I repeat, there are no off-campus passes for lunch. All right, Eagles, have a great rest of your day.
All right. So the same thing you heard yesterday, by the way. All right, real quick. Here's what most people are doing here. They're actually doing it both ways. Said they were doing it option number 1, where they're just writing those two out. This is your base, this is your height, and they're multiplying those together. So the 2x and the 2x is a 4x squared. The 2x and the 5 is a 10x. Then we do the 1 times the 2 is a 2x. The 1 times a 5 is a 5. We write that in descending order, so the 4x squared goes together. We add those two up. So if you get this, then you did that correctly. Okay. Now, what a lot of people are doing here, they're going ahead and finding this. We'll let you go. We need to get the people in class so they don't get lost and can get to class on time. So we'll pick up tomorrow, bring this tomorrow, we'll hopefully be able to finish it. All right, see you guys.